Hello everyone, welcome back to MacroLearning, the organic chemistry part with alkanes. So draw all constitutional isomers of C5H11Cl. So what it is, it's a chlorinated alkane. And what alkane is it? It's 5 carbon molecule, so it's a pentane. So it's chlorinated pentane. So what I would do is to draw out the alkane part first, and then add the chlorine as a substituent. So let's see. So the simplest structural or constitutional isomer of pentane would be simply the 5 carbon straight chain, and based on that, what kind of chlorinated product could there be? There could be chlorine added on this carbon at the end, or let's use this one as one of the bases. So could be there, or a third possibility, chlorine is on the carbon in the middle. So that's pretty much all it is for a straight chain pentane with chlorination. So how about the branch ones? Remember, 1 carbon down at a time. Alright, so we slash off 1 carbon from the chain, and then we have this new 4 carbon chain. And where can we put the branch? Without changing, again, without changing the main chain. If you put the branch here, well, it goes all the way back to the straight chain, and it changes the 4 carbon main chain. Now we've got to maintain this 4 carbon main chain when we play around with the substituents. So the substituents can only be here or here, right? And being here or there would give us the same structure. So this is the only pentane structure that has a 4 carbon main chain. Is that right? Okay, so based on that, where can we put the chlorine? It could be, of course, on this carbon. Okay. Any other possibility? Yeah, it could be on this carbon. And anything else? Let's see. Yeah, could be this carbon. Does that make a new structure? Yes, yes, it does. And there's what? Where else can the chlorine go? Here. Okay. So that's it for this kind of branched pentane. Branched pentane having a 4 carbon main chain plus a methyl substituent. And can we further shorten the main chains? 1 carbon down at a time. Now 2 carbons down, like that. We're left with a 3 carbon main chain, and the substituents could be 2 methyl groups, or it could be 1 single ethyl group, right? But with the ethyl group, it doesn't work, because if we put it all on this middle carbon right here, that's going to change the main chain. Now it's a 4 carbon main chain, so it doesn't work. We have to maintain a 3 carbon main chain at this time. So the only option will be to have 2 methyl groups, both on this middle carbon, and it doesn't change the main chain. Okay, well, you can say it's changed, but it's still the same. with the same substituents. So it is a legitimate new isomer of pentane. And where can we put the chlorine onto this molecule? One possibility there. Any other possibility? Anything else? Well, these three other carbons are equivalent to this one carbon, so they don't count. You can put a chlorine on any one of these, but it's not going to make it a new isomer for C5H11Cl. So what about this central carbon? Can we put chlorine off of this carbon? No, because that would give the carbon 5 bonds, and by now I hope you know that that's never going to work. Okay, so a carbon can only be connected to 5 other moieties. 5 other can be connected to a maximum of 4 other moieties. 4 others. Okay. Anyway, so this is not going to give us anything. So for 3 carbon main chain, substituted chlorinated alkane or chlorinated pentane. That's it. That's the only possibility. And are there any other possibilities? I'm sorry. Can we make it take off one more carbon from there and make it a 3, make it a 2 carbon main chain like that? It's not going to give us anything. We have 3 carbons to be used now as substituent, and you just count, make a new isomer anyway. You can try put substituent here or here, but it's always gonna change the main chain. So 3 carbon main chain is the shortest main chain we can get for pentane without duplicating structures, without missing any possibilities. Okay, so that's it. Chlorinated pentane. These 8 structures are the only constitutional isomers for the formula. Okay, hope you get the idea, and thank you very much. See you next time.